NASA's Perseverance rover, which is currently roaming around Mars, has dropped off the mini helicopter Ingenuity ahead of the aircraft's historic first flight. The ultra-light aircraft had been fixed to the belly of the Perseverance rover, which touched down on the red planet on February 18. The helicopter had to go through a multi-day flipping process from a horizontal position on the rover to a vertical position before it was set down. After Ingenuity is separated from Perseverance, it drew power from the sun using its onboard solar panels to power and heat itself. In one of the last tests, before attempting to take off, the helicopter warmed up its rotor blades, moving them at a speed of 50 revolutions per minute, which is still much more slowly than the blades will spin during the actual flight. NASA will conduct one more test on the ground to more closely mimic the rotor's airborne speed of 2,400 RPM before the helicopter takes flight. If the full-speed spin test goes well, NASA expects Ingenuity to fly as early as Wednesday, April 14. The Perseverance rover is about halfway through the drive from Ingenuity's airfield to the overlook about 60 meters away, where the rover will be stationed to watch the flight attempt through its cameras. Meanwhile, the Mars Entry Descent and Landing Instrumentation 2, one of the crucial technologies on the Perseverance's protective aeroshell, collected and beamed back critical data about the harsh environment of Mars during Perseverance's entry through the planet's atmosphere. Medley 2 included thermocouples, heat flux sensors, and pressure transducers that measured extreme heat and pressure during entry. It also contained electronics and hardware for recording the thermal and pressure loads experienced during entry and through the parachute deployment. The peak measured temperature in the heat shield during the entry was 1,000 degrees Celsius. Surface pressures were also measured throughout the same phase, with heat shield's peak surface pressure reaching at about 29 kilopascals. Medley 2 also used its embedded thermocouples to determine how much of the heat shield protective insulation may have burned away or ablated. All of the thermocouples survived the entry heating pulse, indicating the heat shield ablation was very low. The data collected will help engineers land future spacecraft on Mars. Check out the links in the description if you wish to learn more about the Ingenuity helicopter and the data collected by Medley 2. Elon Musk's brain chip startup, Neuralink, released footage on Friday showing a monkey playing a simple video game after getting implants of the new technology. The 3-minute video by Neuralink shows Pager, a male macaque with chips embedded on each side of its brain, playing Mind Pong. Although he was trained to move a joystick, it is now unplugged. He controls the paddle simply by thinking about moving his hand up or down. Neuralink works by recording and decoding electrical signals from the brain using more than 2,000 electrodes implanted in the monkey's motor cortex regions that coordinate hand and arm movements. Using these data, the Neuralink team will calibrate the decoder by mathematically modeling the relationship between patterns of neural activity and the different joystick movements they produce. Musk has boasted about Neuralink's tests on primates before, but this is the first time the company has put one on display. During a presentation in 2019, Musk said the company had enabled a monkey to control a computer with its brain. In August 2020, the company did a live demonstration of the technology in a pig named Gertrude. Theoretically, this same tech could be used to give people control of synthetic limbs via a Neuralink brain implant. In a tweet Thursday, Musk said the first Neuralink product would let people with paralysis control a smartphone. According to him, later versions will be able to shunt signals from Neuralinks in the brain to Neuralinks in body motor or sensory neuron clusters, enabling people with paraplegia to walk again. In preparation for the agency's future lunar missions, NASA conducted 2 separate ground tests of their SLS rocket components at their test facilities. On April 6, NASA conducted a water drop test of a test version of its Orion Crew capsule. The test only lasted a few seconds and saw the 6,300 kilogram test capsule, an identical replica of the flight article, plunging into the hydro impact basin at NASA's Langley Research Center in Virginia. The capsule was positioned approximately 2 meters above the water for the test, where it was released and impacted the water as planned. The test serves as part of a series of drop tests to finalize computer models for loads and structures prior to the Artemis II mission. For the drop test, engineers at NASA Langley loaded more than 500 sensors into the mock spacecraft to measure the forces acting on the test article during the impact event. With these kinds of tests, NASA is ensuring that both the Orion spacecraft as well as the astronauts inside are safe during future landings. NASA still has at least 2 more drop tests to complete, including a higher altitude drop test and a swing test, where the crew module will be swung into the water at an angle, similar to a rope swing. On the same day of the water drop test, NASA conducted a second RS-25 single-engine hot fire test as part of a new series to support the development and production of engines for the agency's Space Launch System rocket. The full-duration hot fire of more than 8 minutes was conducted on the A1 test stand at NASA's Stennis Space Center. It is part of a scheduled 7 test series designed to provide valuable data for Aerojet Rocketdyne, the lead contractor for the SLS engines, as it begins production of new RS-25 engines for use after the first 4 SLS flights. During the new test series, operators will focus on evaluating new engine components and reducing risk in engine operation. During the test on Tuesday, operators gimmeled the RS-25 engine using a new NASA-designed vector control system for the first time since it was installed. The RS-25 engines for the first 4 SLS flights are upgraded Space Shuttle main engines, and they have completed certification testing. The Soyuz spacecraft carrying 2 Russian cosmonauts and 1 American astronaut arrived at the International Space Station a few hours after its launch from Kazakhstan. A Soyuz 2.1A rocket lifted off from the Baikonur Cosmodrome on April 9, placing the Soyuz MS-18 spacecraft into orbit. Less than 4 hours after the launch, the spacecraft docked with the station's Razvet module. The Soyuz brought to the station NASA astronaut Mark Van High and Roscosmos cosmonauts Oleg Novitsky and Pyotr Dubrov. They will remain on the station through at least October as part of the Expedition 65 crew. The next crew mission to the ISS, SpaceX's Crew Dragon Crew 2, remains scheduled for launch on April 22. It will transport NASA's Shane Kimbrough and Megan MacArthur, ESA's Thomas Pesquet, and Akihiko Hoshide of the Japanese Space Agency to the station. 4 days before the Soyuz crew's arrival, on April 5, the Crew Dragon spacecraft Resilience undocked from the forward port on the station's Harmony module, moved out 60 meters from the station, and then shifted into position to dock with the module's Zenith port. The port relocation maneuver, with 4 astronauts on board, is the first done by a commercial crew vehicle at the station. The astronauts moved Resilience to a different port on the space station to make room for the Crew 2 mission arriving later this month, which will dock at Harmony's forward port. This in turn will free up the Zenith port after Resilience returns to Earth in late April for the next Cargo Dragon mission, scheduled for June. Now, let's discuss some of the major Starship updates from the past week. Just 9 days after Starship SN-11 conducted a fog-cloaked test flight that ended in an explosion, SpaceX has transported Starship serial number 15 from its Boca Chica rocket factory to the launch and test site. According to Elon Musk, SN-15 exhibit hundreds of design improvements across structures, avionics, software, and engine. One of the notable changes is in the design of the thrust puck of SN-15. The methane manifold seems to be external now, with the methane downcomer attached to the inverted cone. On the exterior, SN-15 is fitted with a greater number of heat shield tiles compared to the previous iterations. SN-15 is mounted with approximately 829 tiles, which is more than double the number of tiles on SN-11. With the increasing number of thermal protection tiles on each Starship iteration, SpaceX is testing the integrity of these tiles under flight conditions. Unlike SN-11, which had its 3 Raptor engines installed prior to the transport, the rollout of SN-15 occurred before any engines were installed on its underside. This is because a thrust simulator is waiting for the arrival of SN-15 on the suborbital launch pad A to test the newly designed thrust puck. The hydraulic pistons of the thrust simulator will press against the base of the vehicle to mimic the force of a Raptor engine, and if SN-15 could handle this force without any issue, SpaceX will then mount the Raptors onto the rocket. After arriving at the launch site on Thursday, a giant crane lifted SN-15 and gently lowered it over the suborbital launch pad A. The workers then secured the rocket on the launch pad. The next day, on April 9, SpaceX conducted an ambient pressure test of SN-15, filling the rocket with ambient temperature nitrogen gas to test its complex plumbing and propellant tanks for leaks. It appears that the test went smoothly as planned. With the ambient pressure test complete, SpaceX will now move forward to conduct a cryogenic proof test and thrust structure stress test, simulating the thrust of 3 Raptors after loading the rocket with extremely cold liquid nitrogen. SpaceX will most likely spend another 1 or 2 days inspecting Starship SN-15 and removing the hydraulic ram used to simulate thrust from the launch mount. Once SN-15 and its mount are cleared, SpaceX can move into static fire tests. A recent public notice of Cameron County ordered a temporary road closure on April 12 and 13, indicating that SpaceX is planning to conduct the next round of tests on SN-15 as early as Monday. While SpaceX is preparing serial number 15 for its suborbital flight test, Elon Musk revealed the reason for Starship SN-11's mysterious test explosion. According to him, during the SN-11 test flight, the ascent phase, transition to horizontal, and control during its free fall back to Earth went according to the plan. But a small methane leak led to a fire on one of the Raptor engines, causing a hard start in the engine's methane turbopump at the beginning of the landing burn, which eventually resulted in the explosion. 4 days before the rollout of SN-15, on April 5, SpaceX transported its first Starship ground support equipment tank from the build site to the launch site, while at least 2 more tanks are well on their way to completion. After arriving at the launch site, the GSE tank got installed on a reinforced concrete stand at the test site. For SpaceX's ambitious missions to the Moon and Mars, Starships would need to be rapidly refueled. A launch facility capable of supporting 5 to 10 back-to-back launches, optimally just a few hours apart, would require many times more propellant storage. Instead of spending a few $1 million to acquire a few dozen new storage tanks, SpaceX has decided to design and build its own propellant storage tanks. Even more significantly, the GSE tanks appear to be virtually identical to Starships. In other words, SpaceX is effectively tweaking rocket parts and turning them into a propellant storage tank. The orbital launch tower construction at the launch site is rapidly progressing. Concrete has been poured into the framework for the massive base of the launch tower last week. A recent FAA filing confirms that SpaceX is planning to catch Super Heavy booster with the launch tower. It describes that SpaceX is proposing a 469 feet tall launch tower with 10 feet lightning rod to lift its new rocket and booster on the launch mount and to catch the Super Heavy booster upon return from launch. The tower will be constructed out of structural steel trusses to allow the mechanical arms to lift vehicles. In a recent tweet, Mr. Musk stated that the load points for the booster catching attempt would be just below the grid fins and shock absorbers will be built into tower arms. According to him, the booster reflight can be done in under an hour after catching it with the launch tower. In a separate tweet, he mentioned that the ideal scenario is to catch Starship in its horizontal glide with no landing burn, although that is quite a challenge for the launch tower. He also suggests an emergency pad landing mode on the engine skirt, with no landing legs. He added that Starship definitely needs reliable landing legs to land on Mars and Moon. A Super Heavy booster thrust dome with 28 Raptor mounts was spotted at the build site last week. This could be the thrust dome of booster BN-3, which is expected to be orbit-capable. 6 Raptor engines were spotted inside one of the welding tents last week. Also, at SpaceX's McGregor test facility, they are currently testing a new and improved version of the vacuum variant of the Raptor engine. The pace at which SpaceX is building and testing Raptors indicates that SpaceX is rapidly inching towards the first orbital flight of Starship and Super Heavy combo. The blunt nose cone inside the white mystery cage got a black cap on its tip last week. A hydraulic ram was spotted being installed onto the nose cone before the black cap was added on top of it. This could be a test rig that puts pressure on the nose cone to mimic the condition the nose cone will encounter at max Q during an actual flight. Now, let's take a look at the current status of various Starship prototypes with the help of this illustration from Brendan Lewis. The nose cone of Starship serial number 16 was spotted at the construction site last week. The nose cone is yet to receive its flaps. The forward dome and methane header tank of SN-20 and a 7-ring stainless steel methane tank section of booster BN-3 were also spotted at the build site. Watch our previous videos on the playlist to get updates on other Starship prototypes. Link in the description. With this, we have covered all the major updates from last week. Please share your thoughts on the latest science news and Starship updates in the comments section. Also, do not forget to subscribe to the channel for more weekly updates. And as always, thanks for watching.